get underway for our final session of the City Festival of Space, and what a good one to finish off on with Thriving in Space. We're going to be crossing to Western Australia very shortly. My name is Chris Cubbage. I'm the Executive Editor and Director with My Security Media. This is the Australian Space Industry, Technology, Infrastructure and Investment Festival of Space. We've been running throughout November. About 17 plus sessions and the like, and we still have one more session. If you're in Sydney, we're partnering with Neighbourhood Earth, and we have a special session on December 7 where we have free tickets to Neighbourhood Earth if you happen to be in Sydney. But let's focus on Thriving in Space, and we'll get underway for our last session. And then at the end of this session also, we will have a closing word of thanks with My Security Media, and also with our co-director in Perth, David Mattray, will be joining us. Before we start, I'd like to give an acknowledgement of country. In the spirit of reconciliation, My Security Media and our partners acknowledge the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respect to their elders past and present, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. And we do hope we have you listening, and thank you very much for joining us wherever you happen to be listening from. We have had over 60 speakers from 5 different countries and 18 sessions throughout the festival. These are available on the acity.space website, so you're welcome to go there and check out the wonderful speakers that we've had. And thank you to all of them and the body of knowledge that they've shared with us. We will be providing some publications after this also, and today's session is recorded and will also be available. But thank you to all of those speakers that have contributed, and also to the panelists that we have on today. Now, thank you also, most importantly, I suppose, is also to our sponsors that make these events able to be happening. Platinum sponsor, Inmarsat, and our gold sponsor, Fugro Spark. Our Women in Space sponsor was Lockheed Martin Australia, and our official media channel is our Space and Defence channel. So if you want to stay in touch, also welcome to check out that website. Thank you to our panelists today, and if they can come up on screen. We're going to be joined by Associate Professor Danail Obreschkow, who is the head of the International Space Centre at the University of Western Australia, and Professor Harvey Millar, Director, ARC Plant Energy, COE, which would be the Centre of Environment, maybe, from Plant Energy Biology with the UWA. Dr. Clare Mouat, with Geography and Planning with the UWA, Dr. Laura Fruhen with Psychological Services with UWA, and Dr. David Gozzard, a Forrest Fellow, International Centre for Radio Astronomy Research with UWA. Panelists, if you can turn your mics on, thank you so much for joining us today.
Thanks, Chris.
Great, audio checks all done. And this is a UWA session, is obviously, but all representing Western Australia there. And I suppose this follows on from what we have done throughout the festival. Is we've had a focus. So we've also had a SmartSat CRC focus with South Australia. So that was on Friday. So this is a great way to finish off the festival with a focus on Western Australia, but also University of Western Australia, one of, well, the leading university in Western Australia, but one of the top universities around the world as well. And the declaration, even though I'm in Sydney, I'm a Perth boy, so proud to have UWA with us today. Dan, you're leading up the head of the International Space Centre. Maybe introduce us to the ISC. We'll stay away from the acronyms, even though this is the City Festival of Space. We couldn't help ourselves. And it's been, I understand you're coming up to your first birthday as well, with a year on, but UWA has been involved in the space sector for some time, no doubt. So yeah, over to you, and then we'll hear from the panel. We'll walk through the panel as well as you sort of outline each of your sort of focus areas, and then we'll get into an open discussion. We've got Alma Mater there as well with Elliot. So, and also Q&A. We'll keep the Q&A till after that we've heard from the panelists, and then we'll get into an open discussion. So Dan, over to you, mate, and very interested to hear about the International Space Centre with the UWA.
Thank you very much, Chris. Good day, everyone. In brief, the International Space Centre is a new hub for research and education at the University of Western Australia. The idea is to bring together about 100 researchers, academics from about 20, even more different disciplines. Now, these academics, they are established staff at the University of Western Australia, and they were so already before the creation of the Space Centre. So they remain autonomous in their research and educational programs, but the idea of the centre is to bring them together to create internal synergies, as well as to give us a face to the outside world, a single contact point, if you will, so that industry partners, government agents, the general public finds it more accessible to interact with us, and that we find it more easy to interact with them. So it is this idea of creating an umbrella with some resources to support the research, but mainly to really be a face to the outside world and propel us into the future, strengthen our research, promote our education, and certainly accelerate our engagement with the public, government, and industry sector.
Wonderful. Thanks, Dan. And I think we'll come back to, obviously, it's there to highlight or badge UWA's space involvement. We had the opportunity to talk to some of the panelists pre-interview as well, and it's one of those, there's a lot of touch points with space that we'll delve into. If we can go to Harvey and the ARCCOE, I didn't look at the COE. Again, the acronyms have got me. Harvey, introduce us to your role and the biology aspect of the research that you're doing.
Sure. So our research is funded by the Australian Research Council. So COE is a Centre of Excellence.
Yeah.
The Australian Research Council in Plant Energy Biology.
Got it. Sorry, I should have known that.
That's okay. But my name's Harvey Millar, as you said. So I'm a plant scientist. So I work not on the outside of plants, not on how they look, but what's happening on the inside, how they work, and what their nutritional content actually is. So our lives on Earth are inextricably linked to plants. They're our food and our fuel and our fabrication materials, and they even make the air that we breathe. So that's not about how they look, it's about what they are and what they do. But as we also live in an environment which is completely dominated by their presence, the very color green in our minds is inextricably linked to plants. And so that, and in fact, we've actually become dependent on them for our psychological well-being. So as we plan to thrive in space, we're really talking about a place where plants are absent. So either we need to imagine a world and our lives without them, or we need a stripped back version of plant life that we can take with us. So food is the most obvious first human need and want, I guess, from plants. And whether you ask a school student or a member of the public, or even a NASA astronaut who's been there, they all say exactly the same thing. And that is, they want a lot less of this,
Yeah.
and they want a lot more of things like this, right? So, but growing plants at scale in space is a significant challenge. It's a competition for room. There's a need for really super low waste, high efficient systems to do that. And they need to use what we can take for space travel, and they need to use what we can find when you think about a lunar or a Mars habitation environment. So our options really are to adapt or breed specific plants from Earth to take, or to make new space plants designed for where no plant has grown before. And yes, there was a little pun there. Now, this can make us sound like we're really grossly unprepared to actually do this. How can we possibly manage that sort of transition? NASA actually say that human nutrition is a red risk for the time on Mars and the trip back. It could break such a mission if we can't solve the issues around human nutrition. But actually, if we look back at human history, we see that for thousands of years, we've traveled around our planet and we took plants with us. We modified them and we grew them in new conditions. And today, genetic modification and synthetic biology means we have even more tools to do that, to take plants where they've never been before. So plant science are really working really hard right now to turn these wants into plants that we can take, so that we can take plants to space that are more than just what we need. It's actually what we want, and allowing us to thrive in space in the same way that we do on Earth. So that's sort of our interest.
No doubt. And obviously thoughts of the Martian movie comes onto play, where the biologist is the most important astronaut there, as they say. But UWA has been, obviously, WA and Australian economy strong in agriculture too, and your biology research would be very strong also. How long would you say that touch point with space and this kind of research you've been doing would extend beyond sort of the launch of the International Space Centre with UWA?
Oh, look, I think the fascinating aspect of this is the convergence of two different sectors. It's actually thinking about agricultural technology and how it can relate to the space sector. It's also a recognition that so much of these advances that we're talking about growing plants in controlled environments, isn't just relevant for the space sector. It's actually relevant for a growing agricultural sector, which is using controlled environments, vertical farming, all of these other aspects. Space really supercharges the need, right, of what will be required, and the focus really on the super efficiency and super low waste that a system would be required to work. And that will have knock-on consequences for both things on Earth and things more broadly in agriculture.
Right.
And in our conversations with people, this really has changed the scene in terms of how plant scientists are thinking creatively, because we're thinking in a completely different realm than we normally would in terms of these sort of developments.
Okay, we're going to be full on the hour, no doubt, on this one, because that's a big topic just on its own in terms of biology. And the other one is geography and planning, Clare. This, I take it, there's probably more the applied sort of science here with space as well in terms of geography and planning and using space-related data. Yeah, if you could introduce us to geography and planning and your touch points with the ISC.
Thank you, Chris, and it's a great opportunity to be here. I come from Wajak Millar lands. I'm a political geographer and a community planner, so that means I'm concerned with the geographies of planning and governance and what it means to be in community. And it touches really strongly with Harvey's points about how we're interdependent with each other and the environment for food, for nurture, for recreation, and for all those sorts of functional as well as flourishing aspects. And planners and geographers are both rich in the understanding of how societies work at frontiers and transformations and conflicts over how decisions are made in multicultural communities and in the ruptures and disruptions we have for crises and climates or health or housing or however that might appear. And so the notions of how we get to thrive in a hostile environment and the very logistical concerns of how do we get the very carefully considered what are we going to take and what can we recycle, both in outer space as the receiving or the spacefaring point and the launching place where airports are being turned into spaceports, the redirection of resources in a planet that's already got entrenched poverty and environmental crises. You know, there's a bit of a luxury element here in looking forward and looking outwards, that what are we going to replicate from those? Can we do better? And what sort of outdated post-war colonial mentalities and legacies in our governance frameworks can we take forward? And we were delighted, there's a group of us in our Thriving and Working Hub, to be the first publication that came out of the program, a group of 5 multidisciplinary women from law, psychological sciences, geography and planning, to talk about governance and the need for a governance framework. So we're not just talking about progress in science, progress in mining development, but also in human society and how we coexist both on planet and off planet. So I'll leave it there.
Before we move to Laura, if I could maybe, with some of the key sort of research points, do you actually have? Is it that broad? Maybe in terms of your domain, out of those 150 researchers, how big is the geography and planning aspect of that, would you say?
There's me.
Okay, got it.
We're a small group of geographers. We straddle a lot of things, but we are a magpie profession. So we like to touch upon different things and bring them together, like an octopus's garden. Sometimes it looks a bit messy, but you need that facilitative, synoptic and integrative capacity to be thinking about these things forward. So, and of course, there are other colleagues in planning that are more connected across Australia, and those are connections that's how we got our publication. They were invited to a special issue.
Got it. Because I'm putting my researcher's hat on. I'm just thinking how rich in research this area is when you talk about all of those sort of different aspects and the interdependence of those and how they relate to each other is quite fascinating. And Laura, sorry.
Quickly to respond to that, there's me in the Thriving group, but I'm sure there's other geographers and planners who are thinking about this, and I invite them to reach out and have a conversation.
Beautiful, there you go.
Yeah.
And I think we will start to do that as well through the festival. We should have showed how many speakers we do have. There is a lot of collaboration touch points there that we want to try and draw out of this as part of our body of work, and hopefully we can put you in contact, Claire, as well. There's a couple come to mind. And Laura, psychological services, we did run a session on mental health and humans in space, just to make ourselves aware that this is a very important part, almost as important as the biology with Harvey on what we eat. It's also how we think and the psychology of humans moving into space as well. If you could introduce us to psychological sciences with UWA.
Yes, yeah. So I'm a researcher in the psychological sciences at UWA, and it's really lovely to listen to Clare, Harvey, and Dan as well, because I hear their descriptions and they talk about the environments that are there, the greenery, the society that could be set up, and the technology that will make this possible. And at the center or around all of those things are humans. So having psychology in the Space Center is really important, I think, because humans are both one of your biggest assets that you bring into planetary travel and habitation, but they're also one of the key risk factors, if you like. So we know a lot from psychological science per se, from research on Earth, but also from great simulation that NASA is running, like the high seas simulation, how humans adapt to different environments. And it's important, I think, to note that when you think about space, there's sort of two things to it. And I think that's come through from what Claire's described already, is that there's great possibilities. You can start from scratch. It's a blank slate. There's a sense of anything is possible. So from a psychologist's perspective and someone who's really interested in workplace psychology, how people work well, how teams work together, there's an opportunity to take what we know from Earth and say, well, let's set this up really effectively and well. So we know for long-term sustainability of any mission that people will work well in space. And on the other hand, what's then also there, when you look at the risky environments, we know from Earth also that there are elements around how humans interact with each other, how they deal with isolation, working in remote locations. And there's a rich base within psychology at UWA as well of people who research resilience, work design, research into teamwork leadership that can all feed into understanding those processes.
And that's a very, again, my knowledge of UWA, you're very strong in the medical sciences as well. So this is a real strong area for you. And David, International Centre of Radio Astronomy Research with UWA. Likewise, WA is part of the SKA, and you've got a long sort of history there as well in this domain. If you could introduce us, and you're a Forrest Fellow as well, but yeah, introduce us to your body of research.
So you mentioned the square kilometre array, and that's what my research group's bread and butter was for during my PhD and for the past 5 or 6 years. And we developed technologies to allow the array to work, basically have lots of individual radio dishes that all have to work together as one telescope. And that's technologically quite difficult to do with the levels of precision we need. So we developed technology to help do that. And what we're now doing is we're taking that technology and other technologies developed for astronomy, and we're translating them to laser communications. So spacefaring has an upcoming problem that's already biting now, and that is the limited amount of data you can transmit on radio waves. There's just a hard limit to how much data you can transmit down a radio wave. And all of our satellites are transmitting to the ground, whether it be weather satellites, defense, Earth monitoring, resource exploration, communications. Elon Musk wants to throw tens of thousands of satellites into orbit for communications, and all of these satellites are transmitting to the ground on radio waves, and there's just not enough bandwidth to go around. There's this enormous bottleneck that's already biting, and that's going to get worse. Lasers can transmit a lot more data than radio waves can, and that's why we use lasers transmitted through fiber optic cables for the internet. It's just you can't run a fiber optic cable to a spacecraft. It's very hard to do. And so we can just transmit a laser through the atmosphere, but the problem is the atmosphere introduces its own problems. When you look up at the stars at night, they twinkle, and that's because the turbulence in the atmosphere is deflecting the light around, and the light dances on the back of your eyeball, and so it winks in and out. And our laser receiver is seeing the same thing. The light is winking in and out, and there's other noise that the atmosphere adds as well. And so we have a much lower data rate. And we need to correct for all that so that we can get this data down cleanly and exploit those at the much greater speeds we get from laser communications. So yeah, we're taking this astronomy technology, applying it to laser communications in the hope of getting a lot more valuable data down to the ground and doing a lot more with these satellites that are always, we're sending up more satellites, and their sensors are getting better. Each satellite is generating more and more data. So there's a lot of cool things we can do with this.
Where is it currently at, David? And there is laser communications on satellites now, but again, they tend to do it more on high security applications. Do you see laser comms sort of becoming more common increasingly? Do you think the technology will be sort of able to get there? Is it more, does it require more power? Is that one of the key issues?
It's not so much power, it's just that it's early days, and so lots of different things are happening. So I mentioned Elon Musk's Starlink satellites. So they communicate to each other using lasers. That's relatively easy because there's no air in the way, but then they transmit radio waves to the ground.
Yeah.
We want to do that final step of using lasers to transmit to the ground. It's just early days. There are other groups, NASA, the German Space Agency, lots of others, they are working on laser communications, but for in different ways and for different projects. So NASA are more focused on the really deep space stuff to get information back faster from deep space probes, whereas we're focusing on the low Earth orbit, where we've got lots of thousands upon thousands of satellites generating time-critical, important data that we need to get down to the ground. And there's just no standards yet. Like, we all rely on standards for transmitting signals across the internet or Wi-Fi or whatever. And because there's no standards formed with laser communications yet, it's all different. And so lots of companies are holding back because they're waiting to see what frequencies, what kind of lasers do people go with, what modulation formats do we go with, while others are trying to push it forward, and everyone's doing something slightly different. So we're going to see the first laser transmitters on satellites for transmitting to the ground go up over the next couple of years. And that, my guess would be, that really starts to solidify standards. People start seeing these things are working. Other satellite manufacturers start thinking, okay, that's what they're doing, therefore that's what we should be doing. And we start to see more progress.
Wow. Look, thank you so much to all of you on that. I think we've got a really good picture on where you're all at. Dan, I suppose, where does the UWA International Space Centre fit nationally? This is a Australian focus as well, and we started off our sessions with national capability, and you've been going for about a year in terms of the actual centre. Yeah, how does this fit into the national framework, and who you might be working with as well and collaborating with?
That's a great question. Of course, what's happening now in the Australian academic sector across the whole country is things like us are happening. So since the creation of the Australian Space Agency, we really had a bit of a kick to get our act together and to, basically collect all the resources that are there and say, well, look, this is the role we'd like to play, this is where we like to lead, this is where we like to join, and so on. And everyone is finding their feet at the moment. And at the same time, we are also defining our role in relation to other space centers. It's clear that UWA has an extreme breadth of research. As a general university, it really brings in space research from all the domains. The ones we've just heard about is really just about 30% of what's going on. There's also all the space medicine, human physiology, microgravity, fuel development, rocket fuel, mining asteroids, and so on. So we have all these different domains. Some of them are at the forefront of international research. Some of them are only just starting. and likewise in different space centers. So what we have done to define our role a bit more clearly is we reached out to other space centers across the country. And there is now a forming forum between major universities with space centers around the country, where the common idea really is to see where we have synergies, where our relative strengths lie, and also promote our role as an academic sector as a whole. So it's a bit of a general answer to quite a specific question, but I think it's just relatively early days to see clearly what everyone's role is. It's very clear that for us that thriving in space theme is a good strength. And for instance, the communications aspect that David spoke about is one of these examples that are at the absolute forefront of research, with Nature publications coming out by the year and so on.
Do you not find the square kilometre array does put Western Australia on the global space map, so to speak,
Absolutely.
And is a real strong point for you?
No, absolutely. And look, I'm always very tempted to speak about the SKA. I'm myself an astrophysicist. My passion really is for why galaxies rotate and why the universe expands, and large computer simulations that answer these questions. And I'm heavily involved with the SKA. Now, the SKA, of course, is an astronomy project, and one has to think a little bit about how that ties in with space. Of course, astronomy is ultimately space. It's all happening in space, but the links to the space industry are not there at every point. It's very hard to draw a link from the study of black holes to the space industry, but it's very easy to draw those links when it comes to building a telescope on the ground. For instance, David Gozzard's communications research all came about through the SKA and the need to synchronize telescopes across large distances and so on. So yes, of course, the SKA is an enormous lighthouse beacon for Western Australia. It is the reason that astronomy and astrophysics became very big in Western Australia, and that we now have one of the biggest astrophysics centers in the country in Western Australia, if not the biggest. Depends how you measure those things. So yeah,
that was kind of where my thinking here is the SKA has been in consideration and planning for a long, long time now. So obviously UWA picked that up. That was all part of the initial proposals to get it into Western Australia as well. It's one of the strengths of that. So I think, again, what I wanted to highlight is this is not new for UWA. This is, you've been going for some time. I think the fact that you've created a centre now is all part of the national strategy. Is that how you were aligning it?
Yeah.
Would you say that's come from the national strategy, or would you say the space sector is kind of moving you towards creating centres for that acknowledgement?
I think a few things to say here. First of all, the SKA, you're right, UWA has played an enormous role in getting that attracted to Western Australia. It's not just UWA though. We are in this big joint venture with Curtin, UWA, and the WA state government. There are 3 equal partners in that joint venture that forms the International Centre for Radio Astronomy Research. I'm part of, David is part of, and so on. And it's really that center that is bigger than a single university that has managed to get the SKA on the ground here, and now securing very significant contracts over the next 10 years for SKA construction. And to me, that is a little bit of a role model for what the International Space Centre might become as well. It is very clear that the opportunities that lie around are larger than what single universities can do. And it's also very clear that this, we call it the triple helix model, where government and industry and universities span together to create innovation. And each of them are, basically partners that you cannot remove from the equation. I think something like this is needed if you want to make Australia a space nation. If these 30,000 jobs in 10 years are actually going to be created, that's sort of what's needed, that coming together of those entities.
One area I want to touch on is you mentioned microgravity. Maybe if you could just give us an insight into that body of research as well.
All right. Yeah, that's kind of a sideline to my own research. I have been fascinated with microgravity since well, childhood probably, but seriously as a master student, 15 years ago or so. When I lived in Europe, and there was an opportunity there to fly in microgravity on their spacecraft. Actually, got a model here.
Nice. I like the way this panel's good with your models. We've had some plants and fruit.
I know. Also, you see, I'm not using a fake background like you guys. Yeah, well, and this is a kind of research I have been doing now for the last 15 years, continuously, almost every year. The idea is you set up an experiment inside this aircraft. The aircraft is really just a civil aircraft that has been refitted with stronger engines, and the wings have slightly been strengthened. And what it does, it accelerates practically to the speed of sound, pitches up the nose, so it goes into that gradual turn. And because it's so fast, you actually get pressed out of that arc, and you can stand upright in the plane, but you're being pressed down. So people standing like this in here. And then as the plane goes about 50 degrees against the horizon, the pilots essentially turn off the engines. And so the plane is no longer functioning as an aircraft, really. It just flies like a piece of rock that has its own inertia and now shoots up because it's got so much speed already. It's got enough speed to shoot up for another 12 seconds, comes to a tipping point, and then goes down. That gives you an arc of about 25 seconds of basically perfect weightlessness. Whenever you are in free fall in physics, you are weightless. Those concepts are absolutely equivalent. So the same weightlessness as on the International Space Station, which is about to fly around the Earth. So here you fly on a parabola a bit lower down. And so the idea is that you have this plane which has been stripped off all the seats and cargo space, and it looks like an empty gym. And in there you set up experiments. Normally there are 10 different teams in there, and each of them has their little corner, and they set up an experiment. And so you perform your experiment during the 25 seconds, and then the plane dives down towards the ocean and now has to basically pull itself out in an emergency maneuver of that diving towards the ocean. And you experience hypergravity again as it comes back to straight flight. So you go from a 2G environment, 0G, 2G, and then you get 2 minutes of straight flight, and you go again, and you repeat it 31 times in one flight.
Wow. I take it it's, where is this occurring? Is this occurring in Australia, or is this overseas?
Well, it is now occurring in Australia with a new company that we have called Being Systems. Well, that's in the making anyway. But that's very new. Those flights, they were all done in Europe, and this is the largest plane there is for such flights. But it's managed. Well, those flights were administered by the European Space Agency, which is very open to international collaboration also outside the ESA countries. So I've been leading these projects from Australia, and I believe it might be the only Australian-led continued research project in microgravity over so many years. So I've accumulated about 500 of those parabolas in my life, which is worth a few orbits around the Earth of microgravity. So
I have heard of pilots making their pens float when they go out, and they same concept, I take it.
Exactly, and it's a magic feeling. It really is phenomenal. But it's also amazing what kind of research you can do. I think in terms of effectiveness, cost per outcome, it is extremely good. Say compared to going to actual orbit around the Earth, which is hugely expensive. These flights are very economical. Of course, there's not everything you can test in 25 seconds. You wouldn't be able to grow plants in that time.
Well, don't say that too early. We might be able to get you. Harvey, can we grow a plant in 25 seconds? That's not a bad go. Otherwise, you're back to the small toothpaste tube.
That's the sort of challenge I expect from Dan. So grow a plant in 25 seconds. Yeah. No, obviously you can't. But one of the interesting things that's been done in plant biology research, and in fact a range of biology researchers, is using random positioning machines, so that you can, in much longer timescales, actually have a biological organism run its whole lifetime with no net gravity on it, right? So
Yeah.
when people have done this with plants, you can mimic what plants actually look like and as they grow on the ISS. So it's quite an effective tool to be at even much lower costs than Dan's planes to do random positioning machine kind of experiments where plants never quite know which way's up. And so their roots and other aspects which would normally be responding to gravity don't. So yeah, there's definitely opportunities there to mimic things on Earth. Which
well, one of the things is like water in space. We've shown that there's water on the moon, and they believe that there may well be water on Mars. I take it that's the critical aspect, but it's also how plants use their own energy, and the use of water is a key one. But again, that has applications here on Earth with climate change and, you know, agriculture as well. How, maybe if you could dive in a little bit further into that area as well, and maybe the real challenges there as well, and potentially the new discoveries.
Yeah, so certainly on the water aspect, I mean, one of the great things that for plants in space is that there's also people there. If there's no people, we don't need the plants. So the plants aren't so much the users of the water, they are in one sense, they're actually the recyclers of our water. So you have plant systems which are a key part of that recycling process of taking human wastewater and waste from washing and other components that people may do, and cleaning and so on, that can be used by plants, and plants are really great at actually recycling, pulling nutrients out of that water so that it's then safe to drink again in a biological way, which is much how our planet works, just a huge buffer of water which sucks things out so that we can have clean water to drink. So yeah, plants are an integral part of that. They will be another user of water. And of course, we want that water recycled back into plant material that we're then going to eat because we're eating that high water content food. If we don't take plants with us and we just take, using props again, this sort of stuff with us, we have to hydrate it anyway. We don't just eat these sort of dry, dehydrated things. So either way, that water need is really a human requirement that plants will actually help us to manage.
I take it's probably also opened up a whole new field of research, knowing that there is water out in space, because it's only been a relatively recent confirmation that there's water. But it should be. I mean, we're still looking for planets with oceans, yet to fully find them or where they are. But again, I take it you don't need a lot of water for plants. Is it something that we don't need too much?
You need water, but I mean, for example, like Australian agriculture, we're in a great position, right? Because we're inherently a water-limited agricultural system.
Yep.
Many countries aren't. Australia is. So we are experts really at the efficiency, water use efficiency in plants. But really it's a question of capture. So in the natural environment, we lose a lot of that water to the atmosphere, right? And we have to get it back some other way, rain and so on. In a closed environment system, you can recycle a great deal of that water just by condensing it back and reusing it. So the water which is not in the plants can be recycled. And the water that is in the plants, you're eating. And so you're recycling it, if you like. So in that sense, yes, there's a body of water that's required. And clearly, if you want to do agriculture at scale, then a water supply will be, well, it will be very, very important in that process, either taking it with you or finding it locally. And obviously taking water with you at the sort of pricing of getting stuff off this planet is the last thing that people want to do, but may be essential depending on what's possible.
And from your knowledge, has there been new plants or biology created as a result of space research?
Absolutely. So NASA will tell you a great deal about how their plant biology research has really been quite instrumental in the use of LEDs for growing plants. These were developed for the low energy requirements that were needed on the ISS and other things. And a lot of research on slow release fertilizer and nutrient supply and all of these things have been influenced by the International Space Station science program over the last couple of decades. So absolutely it's inspired, but it's been a very small laboratory, really, the ISS for plant science. So only about 0.5% of the ISS is actually available for anything you might call plant production or plant science. So it's a very small investment of time. And so you haven't had anywhere near as much research as that will be going on in the near future as people actually seriously start thinking about the need to be producing food in space for the return mission from Mars, and indeed while astronauts are on Mars.
I don't have a prop, but I mentioned Neighbourhood Earth on here in Sydney has a module from the International Space Centre, a model of it, it's not the real one, but yeah, there is plant research and biology research in that module. So again, if you're in Sydney, welcome to come along and check that out. But again, it's a small window. It's not like the whole module there. It's just a small part of that that you can see growth on. So yeah, as you say, it's still a relative, despite its importance, still relatively small in space.
But the great thing is, so NASA tells us that their plan, even though there's probably only a square metre of space currently used for plant biology in space, by the mid-2030s, they expect to be 150 square metres of space in orbit around Earth that's being used to explore this question of space agriculture.
Wow, and we talk about vertical farming, potentially, who knows? You could have a vertical farm orbiting Earth if things get really bad on Earth. Yep. And Laura, one of the questions I had is, from your understanding, humans, traveling for a long period of time, to Mars and the like, in small teams, very doable, or do you think there is quite a lot of challenges that need to be considered along the way? They're doing research now in terms of the Mars missions and getting humans to Mars. Just basic human psychology. Yeah. How challenging do you think that really is?
I think so. In answering your question, I think it's doable, but as you recognize, it's going to be a challenge. Ultimately, what you're looking at is an environment that's isolated, confined, and extreme. So you'll have a bunch of people, obviously they'll be carefully selected and trained, but still they'll find themselves for a very long time in an environment that is hostile, not very familiar to them. They are also exposed to potential risks. And we know that from the simulations that NASA has been running, that the longer their simulated space missions run, the more or the stronger the implications are for mental health of the people that they send into space. So it's really, that's what we're looking at is something like loneliness, isolation, and also lack of social connection. And I think this is where David's work really comes in as well. Having the option to connect back to Earth will be incredibly useful. I myself have done research into FIFO workers and how they cope working in remote places. Obviously, the Pilbara is not Mars, but we can learn something from the
pretty close
human behavior from that. We know some of the things that will help those workers. And the other thing I think is also what's important is that you're ultimately looking at teams. So you've got people who work in hostile environments together. And we know from research on Earth that actually what happens in teams is when you have an external threat, very often people tend to lose their team perspective and they focus and adopt an individualistic perspective. And that really affects team cognition. And the other thing related to specifically space travel is that we know when there's a hostile environment or an external threat, that the social fabric in teams is also something that is important and often is attacked in some way or affected by it, let's say. So for example, you've got interpersonal friction or tension that may affect how the team works together. And that very often also shows up in the NASA simulation when they do have people in these enclosed environments over prolonged periods of time.
And go, Claire. I missed that raised hand, but I was coming to you. Go.
I just wanted to follow on from that because some of the latest research that's sort of getting some profile attention is about putting people into simulations for longer and longer periods. And one of the things that follows on from Laura's excellent points are about the loss of connection with the original, with Earth, basically, who are supposed to be there to support and help make decisions. And there's a tendency to have an expression of concern about this autonomy that's being developed. If we're going to go into a spacefaring age, then there will need to be considerations of what does that autonomy look like when communications break down, if you're actually going into settlements and bringing in more people at larger scales for mining and development. Avatar scale might be a bit beyond the reach, but that sort of thing you can imagine. There's going to be need to considerations of what does it mean for labour laws? What does it mean for governance regimes? What does it mean for you know, without it turning into Lord of the Flies or something dramatic, how can we actually set up that eventual fostering of, we are going to be moving potentially beyond the limits of communication and connection to be sovereign in that space? And, you know, how do we actually then absorb that? And you can see behind me, there's probably lots of utopian space fiction books where people have thought about this in very fantastical ways, but how do we actually bring that into meaningful, multilateral and just and equitable mechanisms? That's a key question to consider.
Absolutely. And I was going to come back to the geography and planning aspects and the way our sort of cities, maybe even around airports, are designed as well. Western Australia is obviously, we've mentioned the SKA and the like, but I'm not seeing it lined up for any launches or anything like that as well. Is anything locally in Western Australia that you're seeing where, in your domain, Clare, that the space sector is really touching the ground in terms of that research and what UWA is doing and its application to planning city environments and the like? Years ago, we used to use the Doller satellite. We used to have it go to Doller and then access space data from satellites and the like. Do you find that planning and space-related data is integrated into planning?
No, well, not really. There's, I mean, Erica Teixeira, who's one of the co-authors on the paper who teaches about space governance, does talk about some of those dimensions. But in the research that we were doing, we found that there was a really interesting land use development tensions in New Zealand, where they're trying to sort of have launch spaces there because it's available land and the resources that are available to manage that. And that's where some of the considerations of how much of this is feasible, how much of it is taking away from the equitable concerns with feeding people on Earth, let alone somebody far away, is a luxury. And there are Indigenous issues around the treatment of space and the colonisation of space, or the work that might be happening on unceded lands. You know, there's interesting dimensions that are being explored through the geographies, and then how they play out in the land development of what does it take to transport or to shift a transport usage from an airport to a spaceport. And so some of those tensions and the environmental costs of doing this, you know, strip this planet so that we can maybe go and live somewhere else, are seen to be high on those small parts of the agenda that we'd like to bring it into the broader conversation.
Nice. And just for the audience, welcome to throw in any questions. We're going to be closing relatively soon. And David, for you, the last one, I thought the more we're looking at doing, well, sort of, I think it's Elon is looking at creating sort of Wi-Fi networks and 5G networks around the moon, I think, and he wants to do it around Mars. Any concepts there on communications between sort of planetary bodies and back to Earth as well, and potentially even back to the use of lasers from the moon, or laser communications? Any insights there that I spark interest?
Yeah, as I say, we've mainly been focusing on getting satellite data from low Earth orbit down to the ground. That's our biggest focus. NASA are focusing on the deep space communications, and but the first goal is getting data back from probes, getting data about Mars or Venus or Neptune or whatever else we're going to, getting that data back faster, getting more back essentially thanks to those speeds. And yes, NASA are wanting to have permanent human habitation of the moon as a stepping stone to going to Mars, and then permanent human habitation of Mars. And so part of this the drive for the laser communications is having enough data bandwidth that you can do useful communications, that you can have the links between Earth and the moon, or Earth and Mars, to keep people comfortable, so they can keep in touch with Earth. They can get messages from family. They can just download cat videos for recreation, that sort of thing.
Right.
The 5G networks and things like that around the moon, that's a different kettle of fish. That is just how you, by our scales, how do you get this data over smaller areas? This is about big, trunking huge amounts of data from one place to another. But yes, these data links are going to be critical for not just mission operations, but for keeping people happy.
Yep. And obviously the security, and Lloyd just made a comment there, security challenges in deploying communication networks. But how much more secure would you say a laser comms is?
It's a lot more secure because it's going in a straight line. You can see what you're pointing at, and
you can still intercept it.
Sorry?
You can still intercept it, I take it, or otherwise you just encrypt that?
Yes, but it's a lot harder. So you can still direct a radio wave, but it's still going to be a much broader beam. So because the laser is a much narrower beam, so even the laser communications and testing satellites that are up, they transmit from space and their beam's only 10 meters wide at the ground. So that means an interceptor has to be within this 10-meter column, and you'll see them. You've got control of something 10 meters around the telescope that you're receiving on. So they are much more secure just from the point of view of difficulty of being intercepted. Your interceptor is going to be between you and your transmitter very, very clearly. And then there are things like quantum communications. So lasers can support quantum communications, which use the laws of quantum mechanics to be able to detect if there is an eavesdropper on the line. And if there is, you just simply don't transmit, or you find a way around transmitting using that channel. So a side project we're working on, but that there are researchers all over Australia and all over the world working on, is getting these quantum communications working at high enough data rates to be useful.
Yep. I'm glad we mentioned quantum. So we've pretty much ticked pretty much every topic we can now. And Elliot, there's a comment here, human psychology. I'd imagine the US Navy has tackled many of these issues when designing mission profiles for their nuclear submarine fleet. So yes, those isolated. Curious what methods they use for selecting appropriate crew for submarine work and how it crosses over with long distance space travel. I take it, Laura, potentially as we close off, you don't want people with no personality either, but you don't want someone who's vivacious and outgoing either. That's a real balance to go. And I imagine just talking to all of you, you're very personable, good communicators. So none of you are going to Mars, I don't think, but how do you find that person? What's the short list for a modern astronaut these days?
I'm not actually familiar with the details around on what basis astronauts being selected, but first off, also everyone has a personality. We're all just different. We do look at personality on several dimensions. So, for example, generally we know people who are very conscientious will do well at work. People who are sociable, able to communicate well, they will be, probably doing well in those environments. But I'm not actually familiar what the US Navy does in those instances. But I think Elliot raises a good point in that submarines are a good analog for space travel. We do have a submarine lab in the School of Psychological Sciences here, run by Professor Shane Loft, and they do a lot of research into team cognition and cognition in general. So how do people process information and how can they detect signals when they're looking at screens and all of that. So it's a great analog to have, and also something that will be very useful for space, I agree.
Yeah. And Dan, maybe just to finish off, and I'll get each of you, maybe if you've got any sort of focus points or what your focus areas will be for 2022 that you were going to be concentrating on. But Dan, from the International Space Centre with UWA, what is your outlook? What's your time frame, and maybe a call to action for the audience if they want to find out more or get involved? So what's your outlooks maybe for the next two to 5 years? Is that how the centre is? Have you got a charter and a strategy moving forward?
Yeah, absolutely. I mean, there are different levels of timelines, of course. The centre has spent its first half year of its existence with consolidating itself, is now in the position to make strategies roughly of the timelines you mentioned. So one very clear focus is to get some of our flagship research projects, such as the plants in space, such as the laser communication technologies, propelled to the national forefront of these fields, and embedded also in the local space industry where possible. Second, we are very interested in creating that network of Australian universities that span together. We're obviously not doing that alone, we're doing that together with them. And that means also making these connections from the academic sector to the Australian Space Agency and to the Commonwealth government and so on. So these are big picture things we are working on. Obviously, the centre itself would like to develop new capabilities as well. So we have apart from the outward-looking strategy, we have an inward-looking one as well, where the centre has a growth plan. As you know, at the moment, universities live in a sort of a two-headed world where there's enormous opportunities in the space sector, but also enormous financial pressure due to a lack of international students. So we live in this weird environment where we have to create a lot from not much. So it has worked so far so well, but yeah, growing through partnerships with the industry, with other universities and governments, that's really our focus moving forward.
Very good. Maybe if we can start as we finish, if we could finish as we started, and Harvey, your outlook for 2022 in terms of this. Obviously, I think Dan's highlighted the challenges for universities, and we've got a new variant, although it doesn't look as bad as what it could have been, but life on Earth is a little bit different into the near future as normal. So universities are being challenged. But yeah, just what your outlook, any expected discoveries or research focus that you have for UWA in biology?
So thanks very much. So we are right now involved in a national and international big collaborative push to build a real network between plant scientists in this area, which is already raising all sorts of really interesting international projects about growing plants remotely in each other's countries, through to thinking about how particular modifications of plants could be enacted using the range of skills from different places and different people. And I guess we're really inspired by trying to make reality of what Mick Jagger taught us all, which is that you can't always get what you want, but if you try real hard, you may find you get what you need. And so that's what we're going to be doing over the next year. Nice.
And Clare, I like your one in championing a functioning governance framework for humans flourishing in space. I'm a bit of a pessimist. Well, I'm optimistic pessimist sometimes in terms of we seem to struggle with these really key points in terms of governance. Do you think we'll ever get there? Do you think, and maybe what are your observations in that into the near future on creating a functioning, workable governance framework for space?
Well, I always tell my students that one of my favourite definitions of planning is the organisation of hope, not in the pink glasses lens, Pollyanna world, but you actually have to organise with a sense of aspiration that you're getting somewhere. And my other favourite definition is that planning is always a permanently unfinished social project. So looking for an end state is actually a problem. You actually want there to be a dynamic that's evolving in a healthy way, and that there are checks for it to be healthy, inclusive, just, and environmentally connected in a more regenerative circular economy kind of way. So yes, there's prospects for it, but it needs to be pushed. If we leave it aside because there's a lot of money being thrown at all these other dimensions, we will lose this opportunity. And we have a really great opportunity to learn from lockdown about how people do not like to have just enough Wi-Fi to look at cat videos. They do want to get out and do stuff. So choosing who's going forward and the principles of well-being and flourishing. And Laura and I and others have been having conversations with space architects and different disciplines within our group to think about what those might look like for the future of work, the future of recreation, procreation, families, beyond just the science and economic productivity, but truly human flourishing. I'll leave it there, but thank you for the contributions today. It's been a pleasure to be part of the panel.
Oh, look, it's been, I could talk to you all day. There's no shortage of topic areas. And Laura, maybe that's one thought in terms of your close of how do you remain focused on this, because it's so broad in terms of those research areas, or are you kind of letting the researchers themselves sort of present research that they want to do? How do you remain a bit more focused and strategic in the work that you're doing?
I think the key for us in the psychological sciences is around stepping back every now and then and reflecting on how our work can contribute to space travel. And personally, what really helps me is to talk to people like this panel, because they open up different perspectives to my own work. And I really value that about the Space Center here at UWA, that it creates these opportunities for collaboration and really also shows us how multiverse and diverse this whole issue is of, if we want to go to space, we need human sciences and geography, and we need the scientists in biology and the psychologists and the space research as well. So it's really, if we want to do this together as humans, I think we need everyone to kind of contribute to it. Otherwise, we won't do it well.
I think that's one thing we've found with space. It's so multidisciplinary. We haven't touched on things like robotics and those areas as well. David, closing off for you, and probably more on the technical side and in terms of the science of space. Maybe if you could highlight the real strengths there at UWA in this regard, and also skills development. Is there a bit of a challenge you find on those high-level technical skills, or do you find that there's hope yet?
UWA and Western Australia in general is in a really great place for certainly, at least my kind of research, the laser comms, the radio astronomy, things like that. Our weather, our climate, relatively cloudless skies compared with most places in the world makes Western Australia an ideal spot. And this is new technology, this is new research. We are training people, the PhD students and the master's students in our group are essentially getting trained up to then go on and be able to operate in these new industries. But we do also have a problem that we're trying to move quickly. And so we want to be able to attract, if there is some new knowledge we need, like say modulation formats for a certain type of data communications, where do we get that from? And we are collaborating with groups in University of South Australia and elsewhere to get this expertise brought in, but we'd like to be able to hire some of us. And COVID and also Western Australia and Perth's relative remoteness has made it very difficult to attract the kind of knowledge and skills we need to be able to push really, really quickly. So there are advantages and there are challenges.
Yeah, and I think speed is a key one, and the pandemic has potentially changed things. WA is unique there, certainly unique in Australia, but unique probably around the world in terms of that geography coming back to as a protection point, and it's probably a good thing. Let that continue to be debated, but again, I think your geography of Western Australia has, again, those strengths and challenges as well, that isolation, but maybe the pandemic has changed that. So look, we've gone the full hour and we could go another one. In fact, into the future, we will continue with these sessions into 2022 and hopefully have each of you back and we can really dive into each of these domains and bodies of research. There's so much there to discuss, but thank you so much. And thank you, Dan, for bringing the team on and having us all together. Thank you very much. Now, let me just share as I close off this panel session. I'm just going to make sure I click the right buttons. And thank you so much to our panel today. Associate Professor Dan Obreschkow, I understand this correctly, Head of International Space Centre at UWA, Professor Harvey Millar, Director, ARC, the Australian Research Centre, Centre of Excellence, Plant Energy, Biology, UWA, Dr. Clare Mouat, with Geography and Planning at UWA, Dr. Laura Fruhen, Psychological Services with UWA, and Forrest Fellow, International Centre for Radio Astronomy Research, UWA, Dr. David Gozzard. Thank you so much to all of you. And we're going to do a closing session now for the Festival of Space, but thank you so much for your time today.
Thank you.
Thank you.
Good on you.
Thank you.